All right, ladies and gentlemen, here we go. We got properties of trig functions. Today we're going to talk about the period, which is the length of where these things start replicating. Eventually, in the next section, in chapter 6.4, we'll talk about what these things look graphically, and you'll see that they're waves. And these waves start repeating after a certain time, after a certain period, they start repeating. Okay, so we'll talk about the period of the signs of and signs of the trig functions. Goal number 2, we're going to find the values of trigonometric functions utilizing fundamental identities. I'm going to talk briefly about these trig identities and say from there, you do not need to use those. And last but not least, it says find the exact values of trig functions of an angle given one of the functions in the quadrant of the angle. That's going to be pretty big. You got to know how to do that. So that's example 6 and 7. Okay. First things first, let's talk about the period of sine and cosine. Where do these things start repeating after a certain time? Function f is periodic. There's a positive number p such that whenever theta is in the domain of f, so is theta of p. And you're like, what are you talking about? Big idea, guys. Sine and cosine work on a circle, right? Sine and cosine start repeating after a revolution of a circle. How much is that? 360. So we say the period of sine and cosine is 2 pi, but again, in terms of degrees, that's 360 degrees. And that's for sine and cosine and their buddies. Okay, so the period of sine and cosine is 2 pi, or we look at it in terms of degrees as 360. So here's the big idea of what this is saying. The sine of theta plus 2 pi is the same thing as the sine of theta. Well, they're saying, hey, if you want to find the sine of 390, all you need to do is find the sine of what? 30. How'd you do that? Subtract 360. Okay, so if I want to find the sine of 390, well, subtract 360 from that. That's a big angle. Just subtract 1 revolution around, or 360 degrees, and now I'm at sine of 30, and now that's an angle I'm familiar with. Okay, and we talked about that already. We've seen a few of those, but now we're talking about it one more time. Now, tangent's a little bit different, and when you look at the graph of tangent versus sine and cosine, it is just different. Sine and cosine is like a wave, okay, where tangent looks totally different. It looks like an S curve going up and down. Will look like this, up and down, like an S. And the period for tangent and cotangent is only half of a revolution. It starts repeating after a period of pi. Or in our case, pi is the same thing as 180 degrees. Okay, so the tangent of 210 is the same as the tangent of 30. 30 degrees plus 180 is 210. So if I wanted to find the tangent of 210, I could just find the tangent of 30 if I wanted to. Now, we normally don't do that, but that is a possibility. So once you get to 180, then tangent starts repeating again. And then it starts repeating again. So it's half of a revolution. Okay? All right, so let's put this in action. It says use the fact that trig functions are periodic to find the exact value of each expression. Do not use a calculator unless you have trouble adding and subtracting numbers together. You can do that. Okay? So for example, I've got the sine of 495. That's a huge angle. So let's subtract 1 revolution from that and see where we're at. So subtract 360. Now, if you need your calculator for that, you can do that. What's 495 minus 360? That's 135. The sine of 135. Well, don't just stop there. Now I want to know, what is the sine of 135? What is so? What is O over H? So we go off to the side and we draw a little triangle. Some of us struggled with knowing how to draw triangles. From 6.1, we said our initial side is here. This is 90, this is 180, so 135 is right here in quadrant number 2. Okay? So that was half the battle. Now we need to make our reference triangle. Okay, now yesterday on the quiz, I saw some people coming across and drawing it to the y-axis. Oh, no, no, no. What do? Drop it like it's hot to the x-axis. Now, hot to the x-axis, hot as an H. When you do the 90, it kind of looks like an H, kind of, right? Drop it like it's hot to the x-axis, not to the y-axis. Now, the most important angle that I find is this guy right here. That is the difference from a straight line in 135. So what is this angle? 45. We call that a supplementary angle, so that's 45. Now let me zoom in a little bit so we can see this nice and pretty here. So that guy's 45, so that means this guy here is 45. And what's across from 45s? I have root 2's for my triangle. Root 2, and this is 2. Now, technically, my triangle is not quite right. I'm missing something. Does anybody know what I'm missing? It's almost right. Just missing a little tiny guy. A little tiny thing. Andrew?
The bottom or the adjacent should be negative.
Yeah, so when I go left and up, when I go left, that is a negative thing, right? So that's a negative root 2. Okay. Now, if you forgot that on this question, it doesn't really affect you because we want opposite over hypotenuse. Which one's opposite? The root 2 positive. So this guy is opposite. And which one's hypotenuse? The 2. This is my hypotenuse. From this reference angle, always the angle closest to the origin. So final answer there is root 2 over 2. So if I type in, to check my work again, I'm in my calculator's in degrees. If I type in the sine of 495 and press enter, I get that, right? Well, that is, if I type in root 2 divided by 2. So now I've checked my work, okay? This is how I check my work, not how I do my work. Any questions there? I got to see the reference triangle, see what you're doing. All right, moving right along. I got tangent of 19 pi. This is in radians. If you want to stay in radians, go right ahead. Remember, this thing starts repeating after half a revolution. So I could keep on subtracting 1 pi over and over until I get something between 0 and pi, or 0 and 2 pi, if you will. Okay, either or. So you can subtract pi, subtract pi, subtract pi, subtract pi. Or you could subtract 2 pi, full revolution. Subtract 2 pi, subtract 2 pi. Now, some people don't like working in radians, so I'm going to go ahead and switch this to degrees. I'm going to take 19 pi and multiply by 180 over pi. So the pi's cancel. And I have no idea what 19 times 180 is. 19 times 180 is 3,000. I got 3,420. Whoa, that's huge, right? Way too big. Well, what do I do then? If that angle is way too big, that's so many revolutions, I have no idea. What do I do? Yeah. No, not divide. Subtract 360. That's 1 revolution. Subtract 360. Oh, I'm going to subtract 360. Well, it's still huge, right? So do it again. And 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 that's 540. Not quite there. 180. There you go. So I'm trying to get an angle between 0. Trying to get an angle between 0 and 360. And there we go. I subtracted, I don't know how many revolutions, a ton. Like 10 revolutions or something, right? I don't know. That's the same as the tangent of 180. Okay? Where's 180? Let's see. I always draw an x and y axis to start. And then I draw my initial side. And where's 180? 90. Ooh, 180 right here. That's 180. Well, yesterday on the quiz, then I was having people drawing like a triangle like this. Is that how we do quadrantal angles? No. This is a circle one. This is one of those side. That quadrantal, that angle is right in between a quadrant, so we call that a quadrantal angle. And then we talked about 3 numbers right there. What are those 3 numbers that we have? Lucy. Awesome. 0, -1, 0. Okay. Now you got to know what those three numbers represent. One of them is tangent. Which one is tangent? Is it 0, -1, or 0? Which one? Huh? The right one, yeah? That one's 0. Okay. So again, why? Because the numbers that I have listed here are always in terms of SOHCAHTOA. We're using that guy here. Sine, cosine, tangent. Sine, cosine, tangent when I list my quadrantals. So good job, gang. So final answer there is 0. No triangle drawn. There's no need for a triangle for a quadrantal. You just use the circle. And that circle, guys, I'm leaving that up for the quiz in the test. It's up there. You just got to know how to use it and what it means. Okay? Any questions? All right, last but not least, I got cosecant of 9 pi over 2. Okay, cosecant of 9 pi over 2. Now, you could just leave this into radians and keep subtracting 2 pi. One revolution, subtract it again, subtract it again, subtract it again, until you get something between 0 and 2 pi. Or convert to degrees. Do you want to do converting to degrees or radians? What do you want to do? Degrees. Okay, so let's convert this guy. So you can do it off to the side. 9 pi over 2 times 180 over pi. So the pi's cancel. What's 180 divided by 2? 90 times 9. 810. Okay? Now, yesterday on the quiz, I asked you guys to give me the answer. What is the cosecant of 810 in your calculator? Okay, so you have to know how to punch that in. Does anybody know how to punch that in if you're just using your calculator? Mike? Okay, so that was one of the questions on the quiz is how do you do that? Just do 1 over the sine of 810, or if you're in radians, do 1 over the sine of 9 pi over 2, just be in radians. So just for fun, what do we get when we do that? So good job, Meg. I got 1 divided by sine of 810. And I should get 1 when I'm all said and done. So final answer is 1. Well, how do we do that by hand? Okay, first thing is 810 is too big, right? 810, oh my gosh, way too big. So what do? Make it smaller. How do you make it smaller? Scotty, how do you make it smaller? There we go. That's the answer. Oh, it's still too big. Do it again. We want an angle between 0 and 360, 0 to 2 pi. Okay. So I'm at cosecant of 90 degrees. Well, that's the same as 1 over the sine of 90. So if I want cosecant, the first thing I got to do is find sine. And now I got to know where is 90 degrees. So I make my x and y axis. Here's my initial side. Terminal side is straight up and down. That's 90 degrees. Yesterday I was having people drawing triangles here. Oh, no. This is, again, an angle right on the quadrant. We call this a quadrantal angle. It's in between quadrants. So triangles are out the window. Now you make your circle. And we gave you 3 numbers here. What are the 3 numbers? What's the 3 numbers up here? 1, 0. U is for undefined. I call it IOU because 1 looks like I, 0 looks like O, and U is for undefined. Now, one of them I need and the other 2 I don't need. Which one do I want? I want sine. What's sine of 90? 1. This is, again, in terms of SOHCAHTOA, sine, cosine, tangent. Sine, cosine, tangent. I want sine. Sine is 1, pluggy chuggy. So now I got 1 divided by the sine of 90, which is 1. And 1 divided by 1 is 1. If they ask me what the secant of 9 pi over 2 is, what the secant of 90 is, that would be 1 over cosine. That would be 1 over what? 0? And 1 over 0 would be undefined. Okay. All right. Any questions there? So that takes care of goal number 1, determine the period of your trig functions. If the number's really, really big, we find what's called a coterminal angle. We find an angle that matches up with it by subtracting 360 over and over until we find something that matches up. Yes, sir. No, that is incorrect. Do not change the angle. No. Yeah, if you're going to use this in your calculator, you'd have to be in radians. So you'd have to change this to radians if you're leaving it there. And it would be 1 divided by sine of 9 pi and then divided by 2. This is a good question because I saw that also. People were doing sine of that flipped. And you don't touch the angle. The angle's the angle. You can't change that. You got to just go ahead and convert to radians and do it 1 over the sine of that angle. Okay, so good question. All right, let's go back to degrees. So if it's got a pi in it, it's got to be in radians. If not, it's going to be wrong. All right, next thing we got to do is determine the signs of our trig functions. I talked about this already, but this is going to be a nice little mnemonic for you guys to kind of remember on how to figure out these signs. Okay, this is going back to when we draw our reference triangles in the 4 quadrants. When I draw this guy here in quadrant number 1, working from this guy, number 1 is you should always know our opposite is always the up and down one. So this is O, this is A, and this is H, right? The hypotenuse will always be positive no matter what quadrant you're in. But as you start moving around, opposite and adjacent kind of switch. It depends between positives and negatives. Well, if I do over to the right and up to plot a point, that's a positive, and that's a positive. So what we have there is opposite and adjacent and hypotenuse are all positive. So in our case, SOHCAHTOA are all going to be positive or greater than 0. So sine, cosine, and tangent, all of those ratios will be greater than 0, be positive. Okay, so I'm going to highlight these guys. All of them are positive. So off to the side, A is referring to all trig functions, and I'm referring to sine, cosine, and tangent. All of them are positive, sine, cosine, and tangent. Any questions on why? They're all positive there. When I switch to this quadrant number 2, hypotenuse is always positive. The opposite leg is going up. That's positive. But the adjacent leg is now what? That guy is now negative. Okay, so when I do cosine, A over H, negative over positive is a less than 0. It's a negative number. Negative ratio. When I do tangent, O over A, positive over negative, tangent of theta is less than 0. The only one that's positive is where this guy, opposite over hypotenuse. The only one positive is sine. So sine, from SOHCAHTOA, sine is the only one positive. So I'm going to put an S in this quadrant. Have you guys seen this thing before? Have you seen this? Never seen that before. Before I go any further, does anybody have questions on what I'm doing? Because sometimes math teachers sound like the adults on Charlie Brown. You guys know what those guys sound like?
Oh, yeah.
Yeah?
John knows.
John knows. What do the adults on Charlie Brown sound like? Yeah?
Pretty good.
Wah, 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 wah. Sound like a horn playing. Wah, 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 wah. Sometimes math teachers sound like that. And if math teachers sound, you just say, hey, oh, hey, Charlie Brown here, guy. Yeah? And then I'll do the Charlie Brown. Which is kind of like this one. Oh, man. But I can put it into terms that maybe that makes more sense to you. All right? So again, on this side, the opposite legs are going up. Right? The opposite legs are up, so that means sine has to be positive. And on the right side, cosine is positive because the adjacent leg's on the right, and on this side, the adjacent leg's on the left. That makes it negative, so that's why cosine's negative there. Okay? All right, so if you have questions, man, raise your hand because some of us struggled on that quiz yesterday. All right, quadrant number 3, here we go. The adjacent leg is left, and what happens with the opposite leg? Here's opposite. That guy's going down. It's yelling timber. That one's going down, it's negative. So guess who's the only positive trig function? The hypotenuse is always positive, but O and A are both negative. So what happens when you do O over A? What's a negative divided by negative? That's a positive. So tangent, O over A, is the only positive trig function. Cosine's not positive because it's negative over a positive for A over H. And cosine, O over H, is a negative over a positive. So tangent is the only positive trig function in terms of so, ca, and so on. Okay, everybody else, sine and cosine, are negative. And then last but not least, when I go to this fourth quadrant here, that adjacent leg is positive, but opposite is still going down. It's still negative. And again, hypotenuses are always pluses. So who's the only positive one here? Cosine. Adjacent over hypotenuse, cosine is the only positive one. Sine's negative because opposite is negative, and tangent's negative. O over A is less than 0 because opposite's negative. So cosine is the only positive one. So we start looking at this guy. How do I memorize that all of them are positive? Sine, tangent, cosine. We use this little mnemonic here. We start in quadrant 1, we do ASTC. And the little mnemonic, have you guys heard this one before? Diego, remember this one? All students take calculus. Okay? All students take calculus. All students take cooking. All students take calculus. All of them are positive. Only sine is positive in quadrant 2. Only tangent in quadrant 3, and only cosine in quadrant 4. And that's because when you start moving around these quadrants, things start becoming negative. Okay, so all students take calculus. So let's put this into action. These are questions right off your test, guys. Something very similar. It says, name the quadrant in which angle theta lies. So the first thing I do is all students take calculus. Okay, now you got to know what to do. You have cosecant. Who is cosecant's buddy? Sine. So if I want to do cosecant, and cosecant is less than 0, that means sine also is less than 0. The reason why that is because cosecant is 1 over sine. So if 1 over sine is negative, that means sine has to be negative. Where is sine negative? Where is the opposite leg negative? Because hypotenuse is always positive. What do we got? Where is sine negative? Where is the opposite leg negative? Diego, you got it? 3 and 4. It's positive. Sine is positive. All of them are positive here, and sine is positive here. So that means it's negative down here, where the opposite leg is negative. Very good. Okay. Now we do the next one. I got secant is greater than 0. Well, if secant's greater than 0, then you should know who his buddy is. Who's his buddy? Cosine. Well, if secant's greater than 0, then cosine has to be greater than 0 because secant is 1 over cosine. So cosine has to be positive. Where is cosine positive? Where is the adjacent leg positive? On the left side or on the right side? 4 and where else? 1 and 4. They're all positive in 1, and cosine is the only one positive in 4, so 1 and 4. Now my answer is where the overlap happens. The overlap is right there in quadrant number 4. And use your Roman numerals so you know what Super Bowl we're on. What Super Bowl are we on? What did we just have? 56. I can't even count that. Oh, man. They should just get rid of the Roman numerals, right? All right. Any questions? Now, if you didn't know how to do that one, you'd be right 1 out of 4 times. Just guess. But this is how I show work on this question. Okay. So I start it up again. I want to do example 5. All students take calculus. All of them are positive. Only sine, only tangent, only cosine is positive. I take a look. I got cosine is greater than 0. Where is cosine greater than 0? Where is it? Adjacent leg positive. Left or right? The right side is where the adjacent leg is positive. That's A and C. All of them are positive and cosine's positive, greater than 0. To tangent, tangent is less than 0. Where's tangent negative? Dan, 2 and 4? You're right, because tangent's positive in 1 and 3, A and T. So that means it's negative in 2 and 4. So it's positive here. All of them are positive in 1, and only tangent's positive in here. So that means it's negative in the other 2. So again, it just so happens they overlap in the same quadrant, quadrant 4. Your answer is not always quadrant 4, guys. It depends on what you got. All right. Any questions? Yeah. All right, let's move along. We got at least 2 more, 3 more I want to talk about. Now the textbook starts introducing these fundamental trig identities here. We also call them the Pythagorean identities. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. You can go ahead and use those as you solve question number 6, or you can do it much easier and follow what I do. So if it does say use your trig identities, you do not need to do it. We will actually see these more in chapter 7, the next chapter. So you can kind of put those in the back burner unless you want to. So as I take a look, I've got cosine of theta is negative 4/5, and I want to draw my triangle in this quadrant. So they blatantly tell me it's in between 180 and 270. So when I'm drawing my angle, 180 is here and 270 is there, so I'm in what quadrant? Quadrant 3. So my initial side, terminal side, that's theta. Well, I make my triangle now. Drop it like it's hot to the x-axis. Never, ever to the y-axis. When they give us cosine, first thing is you should know his buddy, because I'm trying to find the remaining trig functions. Who's his buddy? Who's his buddy? Secant. So if this is worth 5 points, you should at least get 1 point automatically. What is secant? What's h over a? Negative 5/4. So you got 1 point right now. So if you don't know what else to do from here on out, at least you got that guy. Now I've got my triangle drawn in quadrant 3, and they gave us 2 sides, believe it or not. They gave us Ch, A and H. Again, so Ch, Toa. They gave us A and H. Well, from this angle, where's A go and where does H go? Where does A go? On the x-axis. This is A, this is O, and this is H from this angle. So this guy is negative 4. Hypotenuse is always positive. If they give you a negative ratio, just remember, hypotenuse is always positive, so the negative gets tied in with either your adjacent leg or opposite if they give you sine or cosine or buddies. Last but not least, I want to find sine. I want O over H. Well, the problem is I don't know what O is. Or do I? How can I find the missing side of a right triangle? Pythagoras. Now, in this case, you don't really need it because you probably already know what it is because it's a Pythagorean triple. What is that missing side? 3. Don't forget we're going down. This guy's going down, negative 3. So that's got to be a negative. So I set up my sine, O over H. That's negative 3 over 5. If I know him, I know his buddy. Who's his buddy? Cosecant. That's ho, ho, ho. Santa's favorite, h over o, which is 5 over 3 negative, so negative 5/3. I like putting the negative on top. You don't have to. I just prefer it. Either one I would accept. So I've got 3 out of the 5 left. I've done 3 out of the 5. I need 2 more. I need tangent. So I need O over A. What's O? What's A? Grace, you got O and A for me? Perfect. Quiz or test, make sure you guys simplify, right? What's negative over negative? Awesome. Grace, good job, girl. And then we got his buddy, cotangent. AO. It's just 4/3. Okay, so again, bare minimum, quiz or test, you should at least get his buddy. Just flip-flops to get secant. But from there, we got to get the rest of it. This is where drawing in the correct quadrant, using your X and Y axes to put you in the right spot is going to help. Okay. Yes?
How did you know to like draw the hypotenuse of a triangle like that?
Right here.
Yeah.
So I know that this is in quadrant 3. So I have no idea where this, initial side. This is telling you where the terminal side is.
Oh.
Okay, this angle's got to be like, I don't know, it's got to be in between 180 and 270, so it's got to be something.
But you're just going off of the quadrant 3.
Right, this guy here, yeah. Good question. But sometimes, and I want to talk about the next one because sometimes they don't tell us blatantly what quadrant we're in. So as we look at the next one, I've got the sine theta is 2/3 and I got tangent is less than 0. If you have no idea how to answer this question on a quiz or test, you should at least know his buddy. Who's his buddy? Who's his buddy? Cosecant. And cosecant is 3s. So at least you got a point, right? Whew. Now, we want more than a point, right? Because 1 out of 5, guys, that's bad, right? That's not good. We want the 5 out of 5. We want that gotcha pencil. So this is where I use that all students take calculus. Sine is a positive 2/3. So where is sine positive? A and S, right? Then they say tangent is less than 0. Well, I know where tangent's positive, A and T, so that means tangent is negative, S and C. They're all positive here, tangent's positive here, so it's got to be negative in the other two. So that tells me I'm right here in Q2. Now, I have no idea what that angle is, I just know it's in quadrant 2. I know it's between 90 and 180. So when I draw my triangle, this is just an arbitrary angle in quadrant 2. I have no idea what it is, and I don't really care. I just want to come up with the 6 trig functions of that angle. Now again, do I go to the y-axis? Oh, no. Drop it like it's hot, make the h, make the 90 with the x-axis. I got O, I got H and A of my central angle right there. They gave me O. They gave me H. The problem is I want cosine, which is A over H. The problem is I don't know what A is. How do I find A? Well, Pythagoras, right? This is not a triple, unfortunately, so I actually got to do Pythagoras. Leg squared plus the other leg. Leg squared equals your hypotenuse squared. Remember, hypotenuse is always the big guy, right? It's like the big brother. He's always by himself, so put him by himself. Okay, these are like the 2 little brothers. You got to have them paired up so they're not scared. That's 4. That's A squared. That's 9er. We subtract 4 over. 9 minus 4 is 5, and we square root. So this is the square root of 5. That's a decimal. Again, no decimals. If that's like the square root of 12, break it down. 4 and 3. 2 and 2 pairs come out. 2 root 3. It's not. It's the square root of 5. Now, if I'm using the square root of 5 and 2 and 3, something's wrong. Because I'm in quadrant 2. What's wrong with my triangle? Little tiny thing. It's got to be negative. It's on the left side. So again, sine is the only one positive. That means cosine and tangent's got to be negative. So this is a negative root 5 over 3. His buddy, secant. Ha! H over A. Flippy flip. That's negative 3 over root 5. If you leave it like that, you're a dirty rat. I had a lot of people, I had to write rat on your paper. Rationalize this guy, multiply by root 5, top and bottom. So final answer. Negative 3 times root 5 is negative 3 root 5. And root 5 times root 5 is just 5. Final answer, negative 3 root 5 over 5. So we're got 2 more to go. All right, so I need tangent. I need TOA. Opposite is what, 2? Adjacent is negative root 5. You can rationalize that. Multiply by root 5, top and bottom. I do not need to see that work. That's 2 root 5 over 5 and with a negative in front. So negative 2 root 5 over 5. Do not take that guy and flip it. Go back to the original and flip that one for cotangent. So cotangent, take the original O and A and flip it so it's AO, negative root 5 over 2. It's way easier. Questions there? Okay, so that's, again, they don't blatantly always tell you it's in this quadrant from this angle to this angle. Sometimes you have to use all students take calculus to figure out where to put this thing. Okay. Last but not least are even odd properties. I'm not, going to make you guys use these even odd properties, but they're here if you want them. This basically says if I want to find the sine of a negative angle, just find the sine of the angle and put a negative in front of it. That's essentially what it means. Now for me, I don't think it's important that you guys use those. Just make your angle in the correct quadrant. Sine of negative 30 is in what quadrant? Where's negative 30 at? Okay. 4? Is that what you said? Okay. So just go down, right? Because it's negative. We're going counterclockwise. Negative 30 degrees. And now make your reference triangle. What's across from 30s? Look over there. What do you got? What's across from 30? 1. Across from the 60 is root 3, and the hypotenuse is 2. Well, I want so. I want O and H. All right, and something's wrong with my triangle. What's wrong? It's going down. Don't forget the negative. And which one's opposite? Which one's hypotenuse? From this angle, what's opposite? This is the OPP. This is the HYP. So we get negative 1/2. Okay. So if you take that exact same, question and try to do it this way, this says if I want the sine of negative theta, if I want the sine of negative 30, just do the opposite of the sine of 30 is what they're saying. So off to the side, you do the sine of 30. 30's here, that's 1, that's 2, that's root 3, across from the 90, across from the 60. And I would do the opposite of O over H, which is negative 1 over 2. That's what that formula is basically saying. Do you need that? If you know how to make your reference triangles, doing negatives going down, you're good to go. Okay. All right. So, ladies and gentlemen, that is it. I don't need to do examples 9. Any questions before we get out of here?